Okay, so on your desks you should have this note glued inside your um, notebooks. I am going to be using two highlighting different colors. So you may want to have some highlighters out on your desks so that you can fill this in. If you don't have highlighters, maybe you can borrow them from a friend and do it after the note is being taken, so you don't have to worry about that. We know from our investigation on Friday that similar triangles, they may not have the same shape, but their sides are proportional. They do have similar things. So sides are proportional and angles are the same. So we have here, there are two similar triangles here. Now I'm going to highlight the similar sides. C to A is similar to N and L. The bottom side of the triangle, C to B, is the same as N to M. And then I'm going to leave that blank side there to show that those are similar. So those are my three colors, the clear or nothing, yellow, and green. So if I look at my first statement here, it says A to C over L to N is equal to B to C over question mark. Okay, so the first thing that I want to point out here is A to C. This is the small triangle, and this is the big triangle. So this ratio here, so I'm going to say that this is small over big. So all of your small triangles have to go on top, or all of your small side lengths have to go on top. So A to C and L and N, those are both yellow. I have B to C is green. Well, what side corresponds to that green side on the big triangle? Well, I look here, I color-coded this. It would be N and M. Okay, the second thing here says angle B is equal to angle question mark. Well, angle B is right here. So in my big triangle, what angle is in the bottom right? Angle M. So I'm going to fill that in. Now, there's another way that you can label a triangle. So we have these sides here. Now I have A over L equals C over something. Okay, so when we have uppercase is talking about it's how this triangle is labeled. Another way I can label the triangle is with lowercase. If I label from lowercase, that's saying I find angle A and I draw a line across, and this is actually side length A. If this is angle B here, this would be side length B across. This is angle C, so across from here would be side length C. So there's two ways to label a triangle. I can call this side here, this yellow side, AC, or I could also call it just B, lowercase b. So again, if I go here and I do this triangle, here's angle L, so across from there, this would be side length L. Here's angle M, this is side length M. Here's angle N, here's side length N. So when I look at this is again saying A over L. So this is again saying small over big. So I'm just writing the small over big because that's going to be important. So it's saying A corresponds with my green side. L corresponds with my green side. So it's saying small over big is equal to C. C is my clear side. So what's my clear side in my big triangle? I'm going to put lowercase n. So these are the ways that we can label a triangle. Now another way I can label a triangle, angles, is this, angle BAC. So angle BAC, I'm going to just choose a different color highlighter. So I'm going to choose this purple one. So I'm going to start at B, then I go to A, then I go to C. What angle is that talking about? It will always be the middle piece here. You can see When I connect B, A, and C, it creates one angle, which actually occurs at angle A. So I'm just going to clear this. So again, just as a reminder, when you have an angle like that, that's actually saying angle A. So I'm going to just draw a little piece there. Okay, so that's my small triangle. Now my big triangle, where would that be? Well, that would be angle L. So how do I write that? I would write this as, now you can do it one of two ways. It means the same thing. You could put M, L, N, or you can do N, L, M. Okay, either way, I would accept that, but the key thing is that means angle L there. Okay, so that's talking about similar triangles, finding matching side lengths, matching angles, proportional side lengths, and matching angles. Okay, so something important here, this little symbol here, this little squiggly, means that it is similar. When that is similar, we know that the sides are proportional. And what have we been doing so far in class? We have been solving proportions. So this statement here, triangle ABC, is similar to G, H, and I. It's actually not G, H, and I. It should be J, H, and I, but that's okay. So what's going to happen here? It says find the length of the missing sides. So we know that these two side lengths are similar. So what I'm going to do is I'm going to highlight the similar sides. There's my purple side on my big triangle, my purple side on my small triangle, blue side on my big triangle, blue side on my small triangle, green side on my big triangle, green side on my small triangle. So what you're going to notice is that I do have some missing side lengths, and this is where our triple proportions came into effect. Now you need to state a rule right away, so actually I'm just also going to write up here, this is my big triangle, this is my small triangle. Now, you get to decide how you want to set up your ratios. You can set them up any way that you would like. Okay, so in order to do this, I'm going to say for all of my ratios, I'm going to write the big triangle number on top over the small triangle number on the bottom. So my big number always goes on top, my small number always goes on the bottom. That's always going to hold true. Okay, so I'm going to write an equal sign. So I'm going to start with a big triangle. I'm going to pick any side length that I want. So let's start with the purple. So I'm going to go purple big over purple small. So that's saying 3 over 1.5 is equal to, let's do blue. Big blue is 4 over, now I don't have a length here, so if you remember, we would call this side here lowercase j. So I'm going to put J there because it's across from angle J. Is equal to, well, I don't have, this would be my big green. I don't have that, but what do we call that side length there? Lowercase b over 2.5. That's how I'm going to set up all of my proportions. So the trickiest part here is setting up the proportions. We know how to solve this from here because we've been practicing this through cross multiplication multiple times. Okay, so again, just to clarify, if I look here, because I have big on the top, all of my measurements in my big triangle should only be on the top. So if I look here, here's 3, 4, and B. And if I look all of my top line, 3, 4, and B. That's good. That's all my big triangle numbers. My bottom is my small 1.5, J 2.5. So all is good here. Okay, so now my first step is I'm going to do some cross multiplication. So I'm going to solve for side length J here. So how do I do that? I'm going to take 3 multiplied by j is equal to 4 times 1.5. And hopefully when you do 3 times j, you get 3j is equal to, and again, you should have your calculator out, and you should be doing these calculations with me. When we do 4 times 1.5, we get 6. And we know our next step is we divide by 3, so j is equal to 2. Okay, my next set that I'm going to do is now I need to solve for side length B. So remember, I like taking my known ratio. So again, if I go here, I'm going to kind of draw it. This would be my green. So I'm going to take 3 times 2.5 is equal to 1.5 times B. And when I do 3 times 2.5, I get that that is equal to 7.5. 1.5 times b gives me 1.5b. What do I do to both sides? I divide by 1.5, divide by 1.5, so I'm left with b is equal to 5. And I've just solved my first similar triangle problem. So again here, what you want to remember is you want to set up your ratios properly. And then that's the biggest step. So this is the only step that we're adding here, is this beginning step right here. That's it. This cross product multiplication, that's what we've been practicing for the last couple of days. Okay, so now we're going to be doing example 3. Now you're going to notice here that the triangles are, so it says here, triangle ABC is similar to LM and N. So I know that they're similar. I also know that they're similar because if I look here, this black line here is the same as this black line. This 2 dashes means that they have the same angles, and these 3 dashes here mean that they have the same angles as well. So again, my goal will be to find the missing side lengths. But first, before I do that, I want to highlight my similar sides. So now the direction has changed, so it's not quite as easy as the one before. So I'm going to do this one here. A and B. Now, if you had to think, what side length do you think would be similar to AB in my smaller triangle? I'm hoping all of you would say L and M. Why? I start at the double blue and I go to the black. Start at the double blue, go to the black. So that's similar there. Okay, now I'm going to do B and C on my big triangle. So what side length would that be similar on my small triangle? I start here from the black angle to the red angle. So I do the same thing here, black to the red. And then my final side here. So now I know what sides are similar. Once I know what sides are similar, I can visually see that. I can decide how I want to write my ratios. So you get to pick. This is my big triangle. This is my small triangle. I'm going to choose to write big over small. Okay, so let's start here. Let's start with the purple side. So I start with purple on my big side is 12.3. Over purple on my small side. I don't know what that is. So what am I going to call that? You could technically call that LM, Or I'm going to go with this single digit. So what angle is that across from? N, lowercase n, is equal to, so my green side. My green side in my big triangle is 12 over my green side on my small triangle is equal to 3. Now I'm at my blue side. I don't know what my blue side is on my big triangle, so I have to call that something. You can call it BC, or I'm going to call it lowercase a. So I write lowercase a over my blue side here, which is 4. Okay, so once again, I'm going to check here. My big should all be on top. So every side length on this top line should correspond to the big triangle here. 12.3, 12a. All of that is on top. That's good. On my small triangle, all of these side lengths on the bottom should all be the small. Lowercase n, 3, and 4. Okay, so that's the tricky part, is setting up these proportions. Now I need to solve. So here's my known ratio. So now I'm going to perform cross multiplication to solve for n here first, just because that was the way that I set this up. So what do I have to do? I'm going to take 3 and I'm going to multiply it by 12.3. Remember, when I draw that x there, it tells me which numbers I have to multiply. And then my next set of numbers I have to multiply are n multiplied by 12. So when I do 3 times 12.3, I get 36.9 is equal to n times 12 gives me 12n. Now I'm going to solve for n here, so I divide both sides by 12. So I have here n is equal to about 3.08. So I round it up. So when you put that in your calculator, you should get 3.075. So I round it up to 2 decimal places. Okay, my next set of cross multiplication is now I'm going to solve for side length A. So I can draw some lines there. And my first set of multiplication I'm going to do is 12 times 4 is equal to 3 times A. And when I do 12 times 4, I get 48 is equal to 3A. I divide both sides by 3, so I'm left with A is equal to 16. Okay, so we are done our note here. You have a worksheet that you'll use the remainder of the class to work on. I will be checking all homework, so those worksheets that were given to you on Friday, the worksheet that you're going to be given today, I'm going to make sure that that is all done for tomorrow. So please use this time wisely to get all of your homework done, and I will see you tomorrow.